Stealth is important to the super sub's survival. But if the USS Texas and her sister, the Virginia, want to survive in this open ocean battlefield, they must see and hear the world around them to navigate, attack, or defend themselves against enemies. The super sub literally paints a picture of her environment with sound.
It's our only way to know what's in front of us, what's to the left, what's to the right, and where we have to go to avoid running into other ships in the sea. Obviously, we don't have windows, so when submerged, this is truth.
The super sub can hear better than any sub man has ever put into the water. It has 10 sonar arrays mounted in the sail, on the sides, in the bow, and one towed behind her, all working with sound to produce a view of the underwater landscape like never before. Each line on the screen represents a contact, anything in or on the water that makes noise, from a whale to a cruise ship to a fishing boat.
This is a merchant ship. It sounds like just a coastal merchant, probably not anything real large. And what you're hearing when we're listening to this is the screw turning in the water and air bubbles forming and then collapsing on the tips and the face of the blades, as well as just the sound of it turning and propelling the ship through the water.
The final piece of technology that allows the super sub to find its enemy lies hidden behind a composite material dome, the spherical bow array. Mounted with hundreds of hydrophones, it allows sonar operators to hear ships in the water up to 1,000 miles away.
Consonar gain new WAD detection bearing 258, designate Sierra 4.
Sonar signals are processed by computers with more number-crunching power than nearly every U.S. sub in history combined. Yet there are some threats that the Texas may simply not be able to hear until it's too late. A technological ghost from World War II has returned to haunt the oceans. The waning days of the war. Using radar, the Allies devastate the German submarine fleet. The Germans realize the U-boat's fatal flaw. Its mechanical engines periodically need air to recharge their batteries. Every time a U-boat surfaces, it's dangerously exposed. A brilliant German engineer, Helmut Walter, devises a way to keep U-boats underwater longer. It's called Air Independent Propulsion, or AIP. The Type 21 U-boat is born.
He had ideas which were revolutionary in a way. So he invented this streamlined submarine, capable of doing high speeds, was far ahead of his time.
The Type 21 accomplishes unprecedented stealth. The secret, a massive bank of batteries that enable the sub to remain submerged longer and still reach speeds of 16 knots, faster than the U.S. convoys on the surface. But the war ends before Germany can unleash air-independent propulsion and the world's first super sub. 50 years later, the concept of AIP resurfaces, both in Germany and Sweden. The Swedish Navy's Gotland measures merely 200 feet, half the size of the Texas. Intended for coastal defense, the Gotland values stealth over firepower. Her secret? The incredibly quiet Kockums Stirling engine. It uses a mix of diesel fuel and liquid oxygen to power a generator, which in turn powers the ship's ultra-quiet electric motor. Encased in soundproofing, the Gotland's engine is so quiet, so hard to detect, that the U.S. Navy has rented her from Sweden for use in war games.
One of the worst things that Texas could encounter is one of the new generation AIP submarines laying in wait that knows the territory, knows where the nooks and crannies around the continental shelf are, and understands the local acoustics.
If Sweden's Gotland-class sub is quiet, this German sub is almost silent. The 212 Alpha. It cannot outrun or outgun a steel shark like the Texas, but it's powered by a chemical reaction so quiet that builders say it can disappear at will. The 212 Alpha, born in the same shipyards that would have built Walter's revolutionary AIP U-boat.
Even design, we are designing the shaping of the submarine.
Today's German Navy isn't building hunter-killers, but sentries and spies to patrol shallow waters. The 212 Alpha's stealth begins on the outside. Its hull design slips quietly through the water, reflecting little sound.
And interestingly, the welding is done on the spot.
Computers cut every piece of the sub, and before workers weld hull sections together, they preheat them to give them maximum strength. A process so incredibly precise, it measures errors in millimeters. When it's finished, the 212 Alpha's even smaller than the Gotland and doesn't need a nuclear power plant or the Gotland's mechanical engine.
We do not need any piston engine generators, clutches, or something like that. The old technology is gone. We have the new technology with fuel cells.
To power this generation of submarines, the German Navy uses fuel cells. Often cited as the ultimate source of cheap energy for homes and cars. This is what the 212 Alpha sounds like when using its conventional diesel engine. When it wants to slip silently below the waves, it switches on a bank of fuel cells. And with a flick of a switch, the 212 Alpha disappears.
Yes, the boat is switched to silent mode now, and we are switching on the fuel cell plant. And the fuel cell plant powers the propulsion engine. This electrical engine runs with more than 1,000 horsepower now, and you don't hear anything. We are a hole in the water now.
The German Navy won't reveal just how long and how fast the 212 Alpha can run underwater on its fuel cells. They say only that it can stay submerged and hidden for weeks on end.
It's fine to have a stealthy submarine like a nuclear, but this is more. This is super stealth.